Hello viewers, in today's lecture we are going to discuss one important definite integral involving Signum function, right? So here we have to solve this integral from minus e to e, and the integrand is Signum of x, right? So here e is the exponential number which is an irrational number, and e lies between 2 and 3, right? So now we have to evaluate this definite integral, right? Okay, so now here the integrand is say phi of x is equal to Signum of x, right? So this is the Signum function, and from the definition of Signum function, we know that Signum function, it takes the value plus 1 whenever this x is greater than 0, and Signum of x is equal to 0 if x is equal to 0, and Signum of x is equal to minus 1 if x is less than 0, right? So here we have assumed that Signum of x is equal to some function phi of x, right? Okay, so now we have to evaluate this integral, and here if we take the number line, so here we have minus infinity, here we have plus infinity. This is the real number line, and here we have minus e, and here we have positive e, right? And between minus e and plus e, we have the point x is equal to 0, right? So towards the left of x equal to 0, we have the numbers which are less than 0, right? So x is less than 0, and towards the right all the numbers are greater than 0, right? So what we will do, we'll split this integral I as a sum of two integrals, that is I1 and I2, right? So I1 is from minus e to 0, right? From minus e to 0, because all the numbers which lies between minus e and 0, they are all less than 0, right? So we have here Signum of x dx, and I2 is from 0 to e, right? Because all the numbers which lies between 0 and e are greater than 0. So here we have integral 0 to e and Signum of x dx, right? So now we can write minus e to 0 and Signum of x. See here all the values of x which belongs to the interval minus e to 0 are less than 0. So Signum of x takes the value minus 1, right? And here we have x belonging to the interval 0 to e, and all the values of x which lies between this interval, they are all greater than 0. So here Signum of x takes the value plus 1, right? So now we have these two integrals, and we can easily solve them by simple technique. And here we have minus, taking negative sign outside, we have minus e to 0 dx, and here we have 0 to e dx, right? And the integral of dx is x, so here we have x, and here we have the negative sign, and the limits are from minus e to 0, and here we have the integral of dx is x, and the limits are from 0 to e, right? So now we can substitute the limits here, and we'll take the difference. So we have 0, x equal to 0, then we have x equal to minus e, and here we have minus e, right? And here we have x is equal to e and x equal to 0. So we have now this is minus minus plus, and then we have minus e, and here we have plus e. So minus e and plus e get cancelled, and we are left with 0, right? So viewers, here we see that the value of this integral which involves the signum function is 0. And now let us see the geometrical significance of this result. Now viewers, let us see the graph of signum of x, right? So when x is equal to 0, then the value of signum of x is 0. So here we have the point at the origin, this is 0 comma 0, and when x is greater than 0, then we have the value of signum of x is equal to 1. So here we have plus 1, and here we have minus 1, right? So the graph of signum of x, it goes like this, and here also we have the line y is equal to minus 1, and here we have the line y is equal to 1. This is y is equal to minus 1, and here we have the open circle which implies that x is greater than 0, right? So we'll exclude these 2 points. Okay, so this is the graph of signum of x. Now in the given problem we have to integrate signum of x from minus e to e, right? So minus e, it lies somewhere here because the value of the approximate value of e is 2.71, and minus e lies somewhere here, and plus e, it lies somewhere here, right? Okay, and now from the definition of a definite integral, we know that a definite integral represents the area under the curve, right? So when we integrate from minus e to 0, right? When we integrate from minus e to 0, signum of x dx, then we get this area, right? So we'll get this area, and when we integrate signum of x from 0 to e, then we have the area this one, right? So in that case we'll have this area, and we see that the value of this integral from minus e to e is 0, right? So why this is 0? Because the area from minus e to 0 is equal to minus e, which we have just calculated, right? And this area lies below the x-axis, so that's why it is minus e, and the area above the x-axis is positive e, right? And see, these two areas get cancelled, and we have the total area as 0, right? So now viewers, there is another way of looking at this diagram. Now here we see that the area of this shaded region which is a rectangle, right? Now this is the rectangle whose length is say e, and the width is 1, right? And the area of this rectangle, right? So we have one more rectangle here, and the length of this rectangle is also E, and the width is also 1, right? So we have here two rectangles of length E and width 1, and these two rectangles, one lie below the x-axis and the other rectangle is lying above the x-axis, right? So the area of this rectangle is length times breadth, which is E times 1, that is E, right? And the area of this rectangle, which is this one, so the area is length times width, so this is again E, right? So the numerical value of the two rectangles is E, right? The areas are equal, but this rectangle is lying below the x-axis and this rectangle is lying above the x-axis. So the two areas, the first one is minus E and the other is E, right? So minus E corresponds to this rectangle and E corresponds to this rectangle, and these two areas cancel each other, and the value of the integral is equal to 0, right? So this is the geometrical interpretation of this integral, right? So this area is minus E, and the area of this rectangle is positive E. The negative area is due to the fact that this rectangle lies below the x-axis, right? And the positive area of this rectangle is due to the fact that this rectangle lies above the x-axis. And when we add these two areas, that is A1 plus A2, so A1 is actually minus E, right? The numerical value is E, but since this rectangle lies below x-axis, so we'll take it as minus E, and the area A2, this is A2, this is A1, so this is E, and minus E plus E is equal to 0, right? Hence the net value of this integral is 0. So this is how we interpret this integral geometrically.